Welcome to this documentary-style explainer. Today, we're setting out to explore one of the universe's absolute greatest mysteries. We're going to build a clear, working mental model of what a black hole actually is, what physics says happens near its boundary, and why its interior remains one of the deepest, most unresolved puzzles in all of science. When you hear the words black hole, what's the very first image that pops into your head? For most of us, it's a cosmic monster, right? A giant space vacuum cleaner ruthlessly sucking up planets, stars, and literally everything else in its path. But what if I told you that image is actually completely wrong? The reality is that black holes aren't magical holes in space breaking all the rules of logic. The really surprising truth is that they're built from ideas you already know and experience every single day. Things like gravity, distance, speed, and limits. A black hole simply stretches those ordinary ideas to their absolute limits. So we're going to strip away the science fiction. We are crossing the point of no return to find out exactly what happens when the very structure of space and time reaches an extreme and begins to break down. Okay, let's dive into this. Here is the map for our journey today. First, the cosmic vacuum myth. Second, gravity and escaping. Third, crossing the event horizon. Fourth, inside the unknown center. And finally, redefining reality. Section 1. The cosmic vacuum myth. Rethinking black holes. Our goal here isn't to get bogged down in heavy scientific jargon. We want to build a real first principles mental model. And the core anchor for our explainer is this. The biggest myth is the magical vacuum. But the reality? Well, a black hole actually works more like an old blocked trade route. When a path becomes blocked, movement slows down and eventually stops. A black hole doesn't pull things in like a vacuum. Rather, the geometry of space near it becomes so incredibly extreme that the physical path outwards simply ceases to exist. It's all about how gravity changes the rules of escape. Section 2. Gravity, Space, and Escaping. Bending the Rules. To really wrap our heads around how a path can just disappear, we kind of have to completely change the way we picture gravity and mass. We'll usually picture gravity as this invisible rope pulling things down. Throw that image away. Instead, imagine placing a heavy ball on a tightly stretched cloth. The cloth dips, right? If you roll a smaller ball in your way, it naturally curves toward that dip. It's not being pulled by some invisible hand. It's just following the shape of the surface. Extreme mass changes the shape of the environment so severely that eventually even light cannot find a path outward. Let's look at another familiar idea: escaping. In ordinary life, if you go fast enough, you can escape almost anything. But near a black hole, it's like trying to row upstream in an impossible river. If the current is mild, sure, you just row harder. But if the current becomes faster than any boat can physically row, no amount of effort matters. Near a black hole, that current isn't water, it is the structure of space and time itself becoming way too steep to traverse. Section 3. Crossing the event horizon, the point of no return. And this brilliantly illustrates our next concept. If the current of space-time gets continually faster, there has to be a definitive line where it overtakes any possible speed, including the speed of light. We call that line the event horizon. Now, movies love to show this as a dramatic, physical wall of tearing energy, but it's actually not a material surface at all. You can't touch it. It's a boundary in causality, a line marking a fundamental change in possibility. Imagine driving over a bridge where, once you cross a certain line, there is absolutely no way back because the road on the far side only slopes downward into a valley with no return route. The line itself looks completely ordinary as you cross it, but its meaning? Absolute. Outside the boundary, escape is possible. Inside it, it's not. And here's where it gets even wilder. It's not just space that gets warped. Time does too. Physics tells us that time depends on gravity. Imagine moving through very thick syrup. You move much more slowly because the environment resists you. From far away, an observer would see clocks near the black hole appear to run slower and slower. The black hole literally changes the rules of what can happen and exactly when. Section 4. Inside the unknown center, where physics strains. Let's move on and see how this builds. We've crossed the boundary. We are now inside the event horizon. What exactly is happening here, where standard physics begins to blur? Inside, it's not just a really deep pit that you're falling into. Think of a landscape where the terrain changes so dramatically that downhill becomes your only available direction.
Inside a black hole, the future itself points strictly inward. You aren't just choosing to go toward the center. The structure of space-time is so distorted that the center lies ahead of you in the exact same way that tomorrow lies ahead of you. It is entirely unavoidable.
As you move into this unavoidable future, you encounter intense tidal forces. If your feet are closer to the center than your head, gravity pulls on them much, much harder. This extreme stretching is playfully, yet terrifyingly, called spaghettification. For supermassive black holes, this deadly stretching happens deep inside, long after you've crossed the horizon. But for smaller black holes, this immense tearing happens right at the edge. So, where does all this lead? To this singularity. So the crucial point is this. When physicists say singularity, it doesn't necessarily mean a literal, physical dot of infinite density exists. What it honestly means is that Einstein's theory of general relativity just stops giving us sensible answers at this coordinate. It's a lot like the ancient map makers who wrote, "Here there be dragons," at the edges of the known world. The center of a black hole is where general relativity, which describes the heavy stuff, and quantum physics, which describes the tiny stuff, are forced to overlap. And right now, our best scientific frameworks do not agree on what happens there. Section 5. Redefining our reality. The map of the unknown. Now, let's step back and look at the big picture. We've replaced the Hollywood myths with a structured mental map. Don't view these principles as just facts to memorize. View them as a map showing how ordinary truths operate at their absolute extreme. Mass bends space. Escape is about geometry, not just speed. The horizon isn't a wall, it's a boundary of what's possible. And time itself bends to gravity. A black hole forces all these truths to entangle at once. This boundary perfectly highlights the line between our solid knowledge and profound mystery. We know the horizon exists, we know time slows down, and we know about tidal stretching. But the exact center, how quantum physics fits into the whole shebang, what happens to the information that falls inside, that remains beautifully uncertain. The interior is a place where our best theory points beyond itself, which leaves us with this final, profound thought. A black hole isn't just a dramatic object floating out in space. It is the ultimate test of how reality itself is organized. If the inside is permanently hidden from us, and time and space can twist so violently that tomorrow becomes a physical direction, what does that mean for the fragility of our own physical laws, the ones we rely on every single day? Think about that next time you look up at the night sky.